Welcome to Energy System Modeling exercise number 1. You can find the exercises from the Moodle page. So here's the folder, and there is exercise 1 PDF and exercise 1 Excel file. So from the PDF file, we can see the assignments. In the Excel file, there are 2 datasets, one from household electricity consumption and one from Finland's energy production, or the time step changes. So you have to process the data in a way that both datasets are complete and have a time step of 1 hour, and some values are missing from the first dataset. So let's open the file, and as you can see, there's the the household electricity power consumption in kilowatts. And you can see already from here that there are 3 values missing, and there are some gaps in here. You can toggle to see how many gaps in there are manually in a way that you press Control and you press downwards with the button. So it always goes to the next value till empty, like this. And what we're going to do is we're going to fill these values in a way that let's just put, for example, the 3 first ones, I might fill just like that. But then I'm going to use an if statement. So I'm going to say if the other cell is going to be empty, so if this equals empty, what I'm going to do is I'm going to take an average out of, let's take this many 7 variables in here, or 6 if this is empty. And otherwise, it's going to be this cell. So now, if this is not empty, then it's going to fill the cells right up till here. That's the same values as on the left column. But now if I go in here, okay, seems that we have a problem in here. So let's try and modify it. Maybe this is supposed to be number. Okay, that didn't fix it as well. So it seems that we have some mismatch in the function here. Yeah, so it didn't give me any complaints before, but now that I see it, this should be average. Yeah, so be careful with those. And let's do it again till the first empty. So now it takes the average out of these cells that it can see. And now if I double click it, it's going to go till the very end. Now we have successfully managed to parse together a vector with, let's see how many elements, 8,760. So as many hours are in a year. So that task was successful. So let's move on to the next one. So this is from Ensoe Transparency Platform. So there's the, let's see if we divide these into columns. So what I'm going to do is I'm going to click from here, Shift Control, and press downwards. So I've selected all of these, and then we're going to go to Data tab, and there is text to columns. So I'm going to divide them. So delimited, and let's see if it's delimited with comma. Seems to be. And now we have all of the produced electricity in here if we're going to take it as a sum. So let's take a sum out of here of all of these. It doesn't matter if there are empty cells or this n/e in here. It can calculate the sum nonetheless. So we can double click that again. So how I'm double clicking it is on the right corner. If I put the cursor in, there's going to be this thin plus, and there's the thick plus. So when it's thin, I can double click it, and it's going to go all the way down so far as the vector next to it extends. So you could think that this is enough, but now if we see the data labels or the time stamps rather, you can see that there's an hourly interval, but somewhere along the line it changes. So rather than having an hourly interval, it's 15 minutes. And it changes right around, let's see, 3,361. So from here. So this is the final value in here. So what we want to do if we're interested in this data, what we can do, you can use, for example, offset function as well. But this is a really brute force solution. So let's take equals average. So this is what we want. We want to continue the data with this 4-point average from here. And every hour, so from 15 minutes till the last value in an hour, I'm gonna take the average. So how you can multiply this in Excel? You don't just multiply one. It takes only the next 4 values, and that doesn't cut it for us in here. And you can't multiply it like this. Rather, you take the first 4, the second 4, and then you multiply it. But then you're left with a whole lot of these blank cells. So what we can do is I'm going to press Control C, generate another tab, and then paste as values. So now Excel has, if these are all selected from here, Excel has an option in here, Home tab, Find and Select, go to Special, and Blanks. So if I'm going to select the blanks, it's going to take a while if there's a lot of data. So I selected all the blanks, and now I can just delete the sheet rows from here. Like that. So let's select all of these. So again, press the first cell and Shift Control downwards and Control C. We're going to go into here, and let's, for example, copy into here, because from here on upwards, we have an hourly interval, and in here, we have pasted the parsed together version of this, or the squeezed in version rather, of this 15-minute interval. So these are, again, in an hourly interval. So let's take from here on upwards and paste into here. And let's see how many cells do we have. And we have exactly 8,760 values in this cell. So that's something we can put into here. So now we have the data set of the first corrected one in here and the second one in here. And let's see till the end, we have the same amount of elements in there. So this is household in kilowatts, and this is Finland in megawatts. And maybe we'll create a time vector, so this, or maybe step. This is 1 hour, but it starts from the first hour and advances to the second one. So this is an average out of that. So 8,760 elements in there. So the assignment was to, let's see, was to draw the time series and load duration curves of the Finland electricity production and household electricity consumption. So time series and load duration curves. So how you can manage to do the time series, that's rather straightforward. I'm going to hold Shift and then Control Shift and downwards. So now I can draw this time series. I can draw them both at once, and the other one doesn't show too well because the scale is totally different. But what I can do in here, again, from the quick layout, so if I activate this one, select the quick layout, and the first one, for example, remove the chart title and maybe also the grid lines from there. And I'm not going to need these ones as well because I'm going to do only one per this figure. And again, we could remove the border from there. I should have done this for both of those at once, but that's good enough. So now we have the time in here. So that is hours. We want this time in here in hours. And this is going to be consumption in kilowatts rather. And this is going to be the production in megawatts. So there you have the time series, and what you can do is, of course, it's better to modify the data set in a way that you decrease, for example, the line width, so it's easier to see. Then you can even add some transparency in there, especially in the long one, since it's even harder to see, since there's so much fluctuation in there. So let's decrease the line width from here, and then maybe add some transparency in there. If I put it to black, and it seems like it doesn't do it too well now, but we can still see the variation to some degree. Okay, so that's the time series. And usually Excel gives you everything in a gray font. So what you want to do is you want to select black font, and you can do the same by pressing F4. You can copy the formatting from one object to another. This one didn't seem to work, so let's press it from there. And I want this to start from 0, so I'm going to put 0 into here. Okay, so the log duration curves. So the log duration curve is only a representation of these values in a descending order. So we could put the household and Finland in there as well. And then I'm going to use the large function. So large. So the array is going to be household. So I'm going to press the first one, shift control, press downwards. And now I have to put dollars into here. So I'm going to press F4 to add dollars. So it's going to lock these cells. So when I copy it downwards, this array doesn't move. And since these time steps are, or the elements are in order for the time in here, I can press C2 in here. And now when I copy it downwards, this is going to find the second largest, third largest, and so forth element from the series. And if I drag it in here, and I want to move this to the Finland position, and this one, again, time, and do it like that. And the easiest way to add a chart into here, or add the series rather, is just to copy and paste. So now I have two series in here, so I can move the other one in here. And let's put that, for example, with the red color so you can see it better. And the same goes for here, Control C, Control V, and moving from here to here. And again, let's set that to red. So there's the time series and log duration curves for these vectors. Okay, so the next one was to, let's see, generate a probability density curve from the original data. You can use, for example, the kernel density estimation for this. This, what I'm about to do, is kind of kernel density estimation, but instead of this kind of a normal distribution function that I'm adding the kernels, it's going to be this kind of a rectangular one. So let's find first let's define the minimum for it. So it's going to be 0, and the maximum is going to be, I'm going to find the maximum number from, let's do it for the Finland one first. So let's find the maximum number from here. And I'm going to multiply it, for example, with 1.3. So it gives me a graph that goes a little bit above the value in the maximum from here. So then I'm going to need steps. So how many kind of boxes I want to generate? So let's take maybe 50. 50 is a good amount. And then let's make a vector from 1 till 50. So I'm going to press 1 in here. And in Excel, you have this fill option. Fill series. Remember to do it in column. Step value 1, stop value 50. And then we're going to, so this is the step. And actually, I can make it in a way that I put maximum out of here. And let's put a couple of more zeros in there. So if I'm going to extend or decrease the amount of this steps, the figure is going to update itself. So that's how many steps. Then we need delta x. So delta x is going to be minimum minus, the maximum minus minimum rather, divided with steps minus 1. So what that means is if I start the first step from this minimum and I always add to the previous one, this dx, and I'm going to dollar it. So log it. So these are going to be the kind of the boxes. So we're going to see how many of the original values fall between here. So the first one is going to be 0. And the second one, we're going to use countifs function. So countifs gives me possibility of making multiple these if functions. So I have to take the criteria. So criteria range at first, Finland. So I'm going to set this one. And this is always going to be remaining the same. So that's why I'm going to dollar it. And then it's going to be quotation mark larger or equal. And now you're going to have to put this et sign, larger or equal to, let's see, it's K17 there. And then let's just copy and paste this one and change from here. I want it to be smaller than this one, like that. Let's see if that works. Yeah, so now it only finds 0 elements from there. And what I can do is, since it's locked down these arrays, I can copy it again. And you can see it finds a certain amount of numbers between this and this. So again, what I can do is I can divide this with the count function from here. So how many elements are there? And let's lock these ones down as well. So now it's going to give me the probability rather than the number amount. So if I were to draw this in XY diagram, or scatter rather, it's going to give me a curve like this. So what this means is there's the probability on the x-axis. So let's put in here. So this is the probability. Probability doesn't have a unit, and in here it's the power, production power. So that's how many megawatts. So let's put this one again to 0 from here, and remove all of the unnecessary stuff from here. And I can do it in a way, again, that I add a 0, for example, into here. So it's going to extend the range. So now, if I'm going to add more boxes into here, it's going to automatically recognize those, and it's going to make it more accurate. So basically, you can change the resolution of this probability density curve by changing the number of these elements in here. And this corresponds to pretty much changing, for example, the bandwidth in this kernel density estimation. So the kernel density estimation can be done, for example, with Python, and that just requires the data from this original time series. So we could take this one, for example, and I have an example on Python how to do it. I'm going to share it in the exercises folder. So let's make a new Excel in which I'm going to put kernel density estimation. Let's rename it again. So kernel density estimation, and let's put the data in here. I'm going to just copy and paste the values into here and close down the Excel file. And in Python, I'm using PyCharm. And in here, this is the code I'm going to share. And let's change the name for this. So there was kernel density estimation, and I'm going to try and see if it works. Okay, so there seems to be an error in here. Something is out of bounds. So I'm going to see a good way to kind of see these errors through is to go to, let's take a new ChatGPT window. And I'm just going to put this error into here and nothing else. Ah, okay, so I must have left the data uh, in here somewhere. So let's see this one through. Might be just easier for me to, rather than going through the code, I'm going to change from here data stash. So this is another file. So I'm going to change this to correspond the data name. And let's take this one out and let's see now if it works. If I missed something from the code. Uh, Seems that I didn't. So then we're going to go to ChatGPT, give the code, and say error, and let's copy and paste this one. That's nowadays coding. Okay, it seems that I made a mistake in here in a sense that I have to have the time. Let's try it again. So I'm going to move it in here. I'm just going to make the time vector into here, and it seems that the code needed to have three columns in there. So let's try if that works. So all of this could be made in Python as well. So I'll provide a code to make this kernel density estimation in Python. And for that, what we're going to need is we'll need the original data. So let's take this, for example, and go to the folder where I have this kernel.py, and I'm going to make kernel density estimation file in Excel. I'm just going to paste the values into here. And let's see, I'll have to change the name of the file. So kernel density estimation is the rest of the file name. Okay, let's see if it works. So it gives me an error. And rather than trying to decipher these by yourself, what you can do is you can go to ChatGPT. I'm going to take a fresh window in here. Let's take totally new one. So like this, I'm just going to put an error into here and see. All of this could be done in Python as well. So what you can do is, for example, use the kernel density estimation. And how you can do that, I'm going to provide a Python code for that. And what you need for it, you need the original data. So let's copy the original data time series, and we're going to make a new Excel file in here in the same folder where I have this kernel.py. And let's put KDE, kernel density estimation. And the code requires a certain name for the column. So let's put data into here and copy paste the values from here to here. And now if I run the code, what I will get is this kernel density estimation with adjustable parameters. This is something that I created by prompting it to ChatGPT. I asked a code in Python that would make this kernel density estimation for a certain data set. So what I also asked for it is to make a drawing out of the result and download the original data from this Excel file. So let's change this bandwidth. I'm going to decrease it. So let's see what it looks like. So it's going to get a bit more accurate, and let's still decrease the bandwidth. So it's pretty much the same thing as decreasing the amount of elements in that Excel file. So that's one way to do it with Python. And in Excel, we can copy the same thing that we did for so this was for the Finnish electricity production. So what I can do is find for the other data set as well. It's going to be 0. We're going to find the minimum, or rather the maximum from here. We're going to have equal amount of steps in here. So the dx is going to be calculated in here. And I'm going to make a little room for it in here. So this is the x for the consumption, and this is the probability density, and this is again the x for the household. So this is x axis for Finland, and this is x axis for household. And then there's going to be the probability density. So similar as in here, it's going to be the same as in here, and previous plus this dx dollared. And again, I'm going to copy these two values, so 0 remains the same, and this is going to be, oh yeah, let's take the function still from here. So it's not Finland, it's the household. Yeah, and these will be transferred into here. And this is 0. So now if I were to plot this dx from here, you can see that it's a little different looking. So in the household version, what this means that there's a lot higher probability of having these low power values rather than just in the Finnish electricity production. This shows that there's a high probability of having somewhere between 6,000 and maybe 11,000. So that's the density function in there. And again, if you want to change the resolution of this density function in here, what you have to do is you just have to cut these, cut the number of elements. So if I press delete from here, you'll see that the density function becomes a lot smoother. So let's make this for both of them. So this is power in kilowatts, and this is or we're going to have to change back for the Finnish version, or the electricity production version, rather. And let's take out the border. Same goes for here. And maybe put the font also in black. So there you have it. There's the probability density function and time series load duration curves. So one more thing to see. So one more thing to see. Do a Fourier spectral analysis. So this fast Fourier transform of the original data and draw the spectral density rather as a function of the frequency. So we're going to use PyCharm because our Tampere University IT classes offer this PyCharm to be used for the students. So we're going to use ChatGPT to make the code. So make it in a way that you can read the original data from the Excel to the Python, and then do the Fourier analysis and return the spectral density back to Excel file. So what I have in here is the original prompt that I used. So give me a Python code that reads data from file data.xlsx. The first column is time in hours. The second is household electricity consumption in kilowatts. And the third one is Finland's electricity consumption in megawatts. I want the code to do a Fourier spectral analysis on both consumption datasets. Determine, seems that I used consumption here rather than production, but that doesn't matter in here. Datasets. Determine the spectral intensity as function of frequency. Draw the results in two separate graphs and write the results also in a results Excel file. So that's what I got from the so that is what I got from the ChatGPT. So there's the code. Your code is probably going to be a little different if you prompt it differently. And I had to make some corrections also to here and there. But this Fourier code, what it does, it uses that data.xlsx. So what I have in here is I just copied time, household, and Finland's electricity production. So we can run the code from here, and let's see what happens. And this is the spectral analysis of household electricity consumption, and this is for the Finland electricity consumption. And as you can see, there's a spike, a high spike, really close to zero. So that pretty much corresponds to frequent. If you calculate the frequency from that, I'm guessing it's the 1 year. And then there are spikes in here. So if we were to go to look into the Excel file, so now I exited the figures, and what it does, it writes this results.xlsx. And what I have in here is the frequency of household. Let's extend this one. So household frequency, household spectral intensity, frequency intensity. So if we calculate the actual frequency, I'm guessing that this is, it didn't take into account that it was in hours, even though I prompted it into the ChatGPT. So I would have to multiply this one with 3,600, I guess, to get a hourly frequency. So now if I calculate 1 divide 1 equals 1 divided with this, of course 0 is impossible to calculate. So the spectral density spike in both cases that is really close to 0 it's this one, so 8,759, so pretty much 1 year. So it's going to find a spectral spike from 1 year, of course, because it's 1 year duration in the series. Also, we're most likely going to find something. Let's draw the spectrum. So intensity is in here. I'm just going to paint those both and delete the one in the middle. So let's see if Excel manages to, yeah. So let's see if we can delete the other. No, okay. Let's just let it be in there on the background. So this is pretty much going to be 0, and let's put, for example, 0.5 into here, and we're going to zoom it in into 0.01. And let's see what kind of spikes do we have in here. So this one equals, for example, 0.0013. So 0.0013 equals that one. So it's 700. Let's put it here, paste as a value. So we'll see, so this is 730 hours. So let's see, 730 hours divided with 24. So it seems that it's a monthly cycle that you can find from there. And another spike from, let's see, for example, this one seems to be rather strong, 0.0023. So 0.0023, somewhere around this neighborhood. So maybe it's around 420. So 420 divided with 24 hours, 17 days. So that's half a month. That's rather peculiar. But in that way, you can see where the spectral density is the highest. And let's put this one to reset so we can see, for example, this one, 0.00833. So 0.0, sorry, 833 was probably like that. Yeah. So that's the x-axis coordinate of this spike. And let's put 1 divided with that. So it's 12 hours. So if we are inspecting, this is the household spectral density. So it means that there is something happening in 12-hour intervals for which this spectral analysis finds high spectral intensity in here. And if you are going to go even to these lower spikes, you're probably going to find the limit for this. So, for example, in here, it should be 1 hour. So you cannot detect anything below that because we only have an hourly resolution. Yeah, but the spectral analysis just reveals which are the time frames that something periodic is happening in here. So that's one way to do this spectral analysis. And of course, there's a lot more to it than just this. So you would have to have a bit more thorough analysis of these figures and numbers, but this is only to get you started. So I'll provide this Fourier and kernel Python files so you can use these ones. And just remember, if there's something in the code that you don't understand, just feed this to, for example, ChatGPT, and it'll explain it better. And one thing about these, for example, this pandas package or NumPy package, if you get a error on not having those packages installed, And a final thing about these packages, for example, pandas and numby, if you need to install those, so if you get an error in your Python project that you have to install these, the easiest way, I think, it is to go from here. So main menu, you press settings, then there's this version control, project and Python interpreter. There's a small plus. It might take a while to load this, but there's a small plus. And when I press, for example, pandas in here, you can install the package. I've already installed it, so I don't have to at the moment, but you just press this button in here.